So here we have a question from JAM 2023 Physics. So this question is considered from the diode, and what they need the current through the battery, that means this value. Okay, but the main problem here, we don't know the diode is on or off, right? If we know the diode is on or off, then it's very easy. By using KCL, we'll know the value of current from these two branch, and we write down that this current is sum of these two current. Okay, so I think you already understand the problem. So now we can solve this problem by two way. One is the type 1. Type 1 is the, whenever you need to calculate the current, that means you need to know the diode is on or diode is off. So you need to assume first, and let's see our assumption is true or not. So first let's assume the both the diode D1 and D2 is on. D1 and D2 is on. Okay, so as D1 and D2 is on, so what we need to do, we need to replace this diode by the forward voltage drop 0.7 volt. So let's redraw the circuit. Okay, so you understand, right? This point is how much the voltage is same as this one is the 5 volt, as here no resistance is there. Okay, so this point is 5 volt, and this point is how much is the 0 volt. Okay, so I consider this current is I1, this current is I2, and this current is I. So that means I is equal to I1 plus I2. Okay, so now calculate I1. I1 is equal to 5 minus 0.7 divided by 1, that means 4.3 ampere. Okay, and I2 is equal to 5 plus 0.7 by 1 is equal to 5.7 ampere. Now you see I1 and I2 is both are positive, right? So that means a current, positive current, flow through the P junction to the N junction, right? That means this is normal thing. That means this diode is on. Okay, but in for this diode, you see the positive current from this direction to this direction, right, from N to P flown, right? But we know that no current can flow from the N to P, right? That means this is a wrong assumption, right? So what we assume that D2 is on, but after the calculation we see D2 is off. So the correct assumption will be D1 is on, D2 is off. Okay, you understand? So that means first we need to assume, then we need to calculate the current, and let's see that assumption is true or not. If not, then just change that one. Okay, so let's calculate the current again with redraw the circuit. This is on, right? That means, and this is off. Off means the open circuit. What will be the I2 is equal to 0. What will be the I1? I1 will be 4.3 ampere. Why? I1 is equal to, this voltage is V 5 volt, this voltage is 0. So that means 5 minus 0.7 divided by 1 is equal to 4.3 ampere. So the answer will be 4.3 ampere. Okay, so this will be type 1. Okay, so next I will do with the type 2. So for the type 2, for the type 1, what we assume, it's on, right? For the type 2, what we'll assume? We will assume both diode is off. D1 is equal to D2 is equal to off. Okay, that means the circuit will be Okay, so this is a, I assume, point A, point A1, point A2, point B1, point B2, right? So just tell me what is the value of BA1, B1 and what is the value of BA2, B2. You can see here as there is no current flow, so that means as there is no current flow from this one, as the diode is open, that means the circuit is open, so no voltage drop. As no voltage drop, VA1 B1 is equal to 5 volt, VA2 V2 is equal to 5 volt, right? Now just tell me when the diode is on, just draw a diode. This potential is V1, this potential is V2, right? If it's a practical diode, then we know if V1 minus V2 is greater than is equal to 0.7 volt, then the diode is turned on. And if V1 minus V2 is less than 0.7, then diode will be off, right? Now you see, in this one, these 2 point, right, the what is the voltage drop? 5 volt. That means positive voltage drop, V1 V2. So here we have V1 minus V2 is equal to VA1 B1 is equal to 5 volt. That means D1 is on. Okay, but here you see this one, you call it A2 B2. For this one, diode will be turned off, as here the potential is much higher than this one. That means this diode is in the reverse bias. Okay, so we will get from here D1 is on, D2 is off. You can see it's the same result with the type 1, right? So what will be the final result? The same. I will redraw again. So this will be replaced by the voltage source. So the current I will be 4.3 amps. I think you already understand. Okay, so if you have any question, you can text me or email me. My WhatsApp number is 7076 900 806. Okay, thank you. Bye bye.
Thanks for your time. Please do share this concept with your friends. And if you like this video, please press the like button. It is really means a lot for me.